So, ladies and gentlemen, welcome to the kingdom of callbacks. We're going to see. So, the summary of this talk is callbacks, promises, observables, and what comes after observables. Okay? What goes beyond RxJS. Let me tell you a little bit about the history of async and the history of callbacks. Let me just do some reset of my thing here. Okay, let's go back. Sorry. So in the beginning, Brendan Eich, he had 10 days to write JavaScript. I don't know if you knew about that. So of course he was in a hurry, right? So he was like very busy coding, and then on the 10th day, someone said stop, and then he stopped. So this picture is a historical picture that portrays Brendan Eich at the moment that he stopped programming JavaScript, okay? And as you see, he was very tired, but he did actually a good job. In 10 days, he was able to make a lot of important things. One of the basic things was just callbacks, okay? Basic stuff. You click on the button, and you want to just register a callback to run this alert. Back in the days, we used a lot of alerts. I don't know if you remember, it was horrible. So this was okay for a while. For a while, callbacks were totally fine until something came along called Node.js. And with Node.js, we had to suddenly fetch things from the database, fetch things from this file system, and then we ended up with code that looks like this. This is hell, okay? I hope that, the font size should be okay. And yeah, this is very bad because it really twisted our brains and it made us go really wild. And it got all this pyramid shape, which is horrible. So some people came with solutions for this. One of them is called async.js. Raise your hand if you have heard or used async.js. It's a very old library by Kaulan. And it helped this problem for a while, that if you wanted to check if all of these files exist, you could do that like this, or you could run things in parallel or in series. And that was nice. In the meantime, jQuery was a thing, and they had this thing called deferred, and that was basically like a promise, and then they started standardizing promises, and we ended up with something that looks like this. So you can convert this type of thing into this type of chain. Of Venables is what they had as a name at the time. And this was okay, but all of these things like async.js and promises were mostly concerned with, I need to fetch this thing from the database, this one thing, not multiple things. So we didn't have promises of clicks, for instance. So around that time, Eric Meyer, who's Dutch at the time, was working on in Microsoft, and he had this idea, what if your mouse would be a database? So you could fetch the latest mouse and query the mouse clicks and that kind of stuff. And he created this thing for .NET called Rx, or Reactive Extensions. And not in a long time, we got Rx for JavaScript, called RxJS. So I've been teaching RxJS for 4 years, and one of the most famous blog posts I wrote. And I've been also I wrote a framework on it, and I've been teaching it in workshops. So I know this thing from inside out. But one of the things that I was curious about was, I don't actually need RxJS for this case. Okay, this case basically listens to an interval. I can show what this does. I mean, it just gives the numbers over time. Of course, I could just do this without Rx. I could just delete this part. I can delete that part. And, this is going to do exactly the same as I had before. So what's the point of RxJS? I mean, we just eliminated a lot of kilobytes, and it was still same functionality. So of course, RxJS have these things called operators, like map and filter and scan, and all of these are very useful. There are over 100 of them. So it's all about the magic of operators and how to use those things to, So I thought, okay, but you could also build operators for these things. So for instance, I could write a filter. I'm not going to go through the details, but I wrote filter here, and then I can apply filter on that same subscribe function that I had with this condition that I only want even numbers. So that's an operator, and I wrote it without RxJS. And this is number 10. And I get even numbers over time. So I thought, OK, I can have operators, and I don't need RxJS. So what do I need from RxJS then, right? One of the things I'm missing, did anyone notice, like I'm subscribing, but I'm not unsubscribing. So it's actually kind of challenging for me to make some kind of unsubscribe here. And that bugged me for a while, because I thought, like, is it really so that unsubscribe is the only thing that we need from RxJS? And I thought about this for a while. And one day, I was in the airplane, and it clicked. And I saw, like, yeah! And I was so excited that I took my phone out, and I attached my keyboard to it, and I started prototyping some stuff. And it came out to be pretty exciting, and this is what I'm going to share with you today. This kind of stuff, okay? So I did this in the plane. You can do it now in the conference. I mean, and not like you can understand this stuff, okay? I promise you, you can understand it. But you need to focus, okay? This might break your brain, okay? Don't hold me liable if you have a problem with your brain. But you can do this. I promise you, you can understand what I understood, okay? And it's going to be fun. Are you ready? Okay, that kind of looks like a yes. Okay, let's go. So I'll start with very simple stuff, and we're going to get to the core thing, okay? I have a function that takes a callback, okay? And of course, I call that callback, and I send the number 10. I mean, of course, this will just say 10, 10 in the console, okay? 10, 10. Of course, I could make that asynchronous. I'll just like do a set interval. Whoops. And I'm going to send every 1 second. Whoops. I'm going to send the number I, where I is 0 at the beginning. And I'm going to increment I. So it's 0, and then it sends increments, and it sends 1, and then it increments, and sends 2, and so forth. So pretty familiar stuff. That it works like that. Now, I want to add unsubscribe, okay? I want to make this thing stop. Okay, let's say after 3.5 seconds, I'm going to sort of, I want to stop this thing. So I'm going to register this thing, 3.5 seconds. I want to sort of clear the interval, but now I'm missing that handle, okay? And I need to capture that handle from the set interval, like that. Okay, and this should probably be a global. So far, so good. Everybody with me? Okay, please be with me. Okay, okay. So this should work. Last final words, right? Usually this should work, and yeah, it works. But this is kind of nasty because I'm like leaking implementation details. I don't want to say clear interval on a global, because what if I would have a set timeout here, right? There should be a better way of doing this. And I thought, OK, what if I put the string start here, and I call numbers with the string stop? OK, that's pretty easy to do. Just add type here, and if type is start, then we set the interval. If type is stop, then we clear the interval of handle. Okay? So far, so good. This is the easy part. The hard part will come soon. Okay? And it still works, I promise you. It still works. Okay. So hard part comes now. I have 2 pieces of code. I have this piece of code, and I have that piece of code. I'm going to call this part here. There's this thing called region. It's just a comment. Okay, I promise you, it's just a comment. But Visual Studio Code knows how to collapse this comment. Okay, it's just a comment. Relax. That's not the hard part, actually. So, and I'll call this part the region consumer and region. I'm going to collapse that. And now I'm going to draw some diagram here, which really helps us. going to put the producer on one side, and I'm going to put the consumer on this other side. So what happens in the beginning? In the beginning, we say numbers start, right? So we're basically sending this message to the producer. We're sending start, right? What happens after that? The producer sends me 0, 1, 2, right? So it sends 0, 1, and 2. And after some time, the consumer, this region of code, sends stop, okay? So I'll just write there, stop. Okay, and now I'm going to share with you my big insight. It took me 4 years to understand this. Okay, it took me 4 years. Okay, in other words, this is like subscribe, and this is like unsubscribe. Right? I'll just call them start and stop. And we know that the consumer is listening to the producer, right? We added a listener, and we're just listening. What are the numbers that you have? So, of course, the consumer is listening to the producer. That's easy. Usually in RxJS, that's the observable, and this is the observer. Now, as these arrows show you, right, we get that. What if the consumer would be listening to, sorry, the other way around. What if the producer would be listening to the consumer? When are you going to tell me start? And when are you going to tell me stop? Now, I don't see your brain clicking just yet. But what I understood is, what if the observer would be an observable, and the observable would be an observer? Right? That's what I thought, like, whoa, this could be something. And I discovered, why is there this listener and there's this thing that can be listened, right? Why can't they just be talking to each other? And I discovered that we could make things symmetric with a symmetry. I'll show you, okay? You're gonna see it. So let me just show you what kind of function we had for the producer. We had this function that took type and CB. It could be also payload. And in the case of start, I know that the payload is a callback. And in the case of stop, I don't pass any payload. Okay, you can think of type and payload kind of like as Redux. There's type and payload, same kind of idea. So with the consumer, what's the kind of signature for the function is basically function data, and it returns nothing, right? That's the signature for this thing. It takes some data, and it just returns you nothing. Also the case here. So I wanted to unify these two types of signature, this type and payload void and data void. So I just did like this. I just said, like, what if here I would also have type and payload? And then this type would be data, and payload would be the data. Okay? Why am I doing this? So that these two sides, the producer and the consumer, can look exactly the same, but they can still plug with each other. So I'm going to do that. I'm basically going to have both of these sides have the same possible arguments, like that. Both the producer can get start and data and stop, and also the consumer can get start, data, and stop. Okay? And I'll show you how we can convert these things. So let's start from the producer, for instance. It's not a region anymore. I'll make a function. So it's just going to call this producer, and this is the payload. And once I start this, so basically once I start listening to the producer, I know that the payload is a callback. Right? Are you with me? Are you with me? Please be with me, because there's no point being alone here. Oh, yeah, I'll just simplify this code a little bit. Okay, so I know that CB is the payload, and I know that the CB, the consumer, has this type of signature. So instead of sending the data, I'm going to send type data and the data. Okay? Okay? Cool. I'll ignore this part for now, and let's go down to the consumer. I'll just make this a function consumer type and payload. And what I'm going to do here is that, well, if type is data, then I'll just console log the payload. That's the easy part, right? This is a listener, and once you say data, it's just going to console log it. But I'm also going to add start for the consumer. So the consumer will listen to the producer. If type, no, I'm sorry, yeah. If type equals start, then I know that the payload is the CB. Okay? And what can I do with that CB? I can say after 3.5 seconds, I will send a message to the producer, and I want you to stop. I can see you confused. Yeah, but once I plug these things together, it's going to make some sense. So the consumer will send start, and the producer will send start, like that. So far, I have just 2 functions. Okay, I have functions like that. So I need to do something so that it works. I'll start listening to the producer. Oops, sorry. But this is essentially like a subscribe, okay? So I'll just say start with consumer. Okay, let's go step by step. I'm basically passing this callback to the producer, right? And with start, this is the consumer, okay? And after a while, we're going to send data to it. But I'll also send the start, right? Because as you see here, I need to send that start. So I was missing that part. Let's put it here. CB start and producer. Okay, what happens after that? This goes all the way here. And now the consumer knows when to say stop. Okay? So both of them are now listening to each other because they're having a conversation. And then the consumer is listening. And after that, the producer will say, you know what, 0. And you know what, 1. And you know what, 2. Right? And then after a while, the consumer says, you know what, I'm done with you. I don't want to hear you anymore. So it says stop. And we go here, and now there's this unhandled case, right? We need to handle the stop. But I have this problem where the handle is not global anymore. That's tricky. So I thought, how am I going to do this? Because do I put this global? That's not nice. I want to do, because the handle is in this block here, I have to somehow have this clear interval somewhere here, okay? So what I'm going to do is, okay, I'm going to add another thing here. This callback is the consumer, I promise you. So I could just rename it like this. And, you know, start means basically subscribe. So I can listen to the consumer with another function. It's a nested callback, like this. And then if the type is stop, then I'll just do clear interval handle. Oh, and then that works. Okay? I know that you're kind of confused, so I'll just go this step by step again. It starts here, line 27. Where does it go? To the producer, start. It comes here, and it knows what the consumer is. It starts listening to the consumer. After a while, it sends data to the consumer. The consumer then, registered that callback, and it also got that data. It got more data, and more data, and more data. At some point, the consumer says stop, and it goes all the way here. And this code works. Okay, I'll show you. Just collapse that, collapse this. One function, another function, and plugging them together. And node 12, it does what we wanted to. And you might be saying, this is kind of like cheating. Like, it looks like hell now. Right? It looks like callback hell. I mean, you got quite twisted there. But the thing is that now I have hell inside a box. Okay? And I have another piece of hell in another box. And I could just plug two pieces of hell together and get heaven. That's kind of the idea. But I'm going to show something that RxJS cannot do, which is the consumer sends a piece of data to the producer. Because they're having a conversation. In RxJS, it's basically like there's a monologue, okay? You can listen to that monologue, and you can stop listening to that monologue, but it's not a conversation. So here, I can send some data to the other side. Let me show you. For instance, I could send data in 17, and then after 7 seconds, I send stop. Okay, so then the producer will receive data, and now P is 17. What could I do with that number? Well, I could do all kinds of things, but I'll just decide that I'll do I equals P. Okay? Yeah. And then it will basically reset this number here. So it's going to say 17, and then the following number will be 18, and 19, and 20, so forth. Okay? And let's run that. 0, 1, 2, and then it says 17 and 18. They're having a conversation. Two pieces of hell. Okay? So this is what I called the callback pattern. Okay? The idea is that you have something nasty you put into the bag, and then, yeah. So it's exactly what I showed to you. And except that I replaced strings with numbers 0, 1, and 2, just to make it like very tight, you know. So, but the idea is that both the consumer and the producer, they are symmetric. They have the same signature. And you can write all kinds of operators for this, kind of like RxJS has. We have, for instance, all of these. And this example is very exciting because you cannot do this with RxJS. And I've seen plenty of questions where people said, how can I pause an observable? Okay, I have an observable, I want to pause it. You can't. You cannot pause an observable, but you can pause a callback because you can talk to the other side and say, hey, stop, continue, and that kind of stuff. For example, here I have a normal like stream of numbers, but then I say, you know, stop for a while, and then continue, and then stop for a while. And this is very simple type of code because you want to see the implementation of this. I mean, I'm requiring some libraries, but these are very simple. Like, this is pipe. It's 4 lines of code. What else? This is interval. It's essentially what I showed you. It's essentially what I showed you before. And you can require even others, like let's say basic map, callback map. And I can put it here, like map each number to that number times 100. Ooh, format for me. And then it's just bigger numbers, right? And map is very simple as well. It's like super tiny. Look, it's like what? 3 lines of code, 4 lines of code, right? So that's good news, actually, because if you want to write real applications, someone wrote to do MVC, David Waller, in callbacks and SnapDOM. And if you compare this with React Redux, for instance, React Redux takes 60 kilobytes, and callback to do MVC takes 7. How does the structure inside those 7 look like? We have on the right the application code, and on the left the virtual DOM library. In the middle here we have something like, I don't know, 10 callback operators. How would this compare with RxJS? If you import RxJS, the core library takes at least 5 kilobytes, and on top of that, operators. The core of callbacks is 0 kilobytes because it's not a library. It's not a library. It's a pattern of writing callbacks. And all of these 1.5 kilobytes include 10 operators because they're just 4 lines of code, 5 lines of code, that kind of stuff. Also, it's slightly faster than RxJS in the benchmarks that I made. But the thing that excites me most is how the community took this. Because, if it's just 5 lines of code, even though it's very tricky and it's like hell in a box, you could write it. I mean, seriously, you just sit down and think about it. You could write it. And that's what people did. So I built some basic operators, like 20 of them. And that was in February. But by now, we have around 110. And most of these were built by the community. So I didn't build most of these. And you can find them in the wiki. If you write one, you can add it to the wiki. There's ways of converting from the keyboard or from the gamepad or interval or Reddit, or converting from observables, converting from promises, converting from Node.js streams, converting from iterables, converting from all kinds of stuff. And you can convert it back to async await. You can convert it to iterables or RxJS. You could transform it in multiple different ways, variations of map, and you can filter them in all kinds of ways. And a lot of the behavior of RxJS is here already. And this is what really excited me, because some of the people who made libraries for callbacks, that was their first library, because it's so small and it's so simple. I mean, it is tricky and intricate, but it's intricate in a box. And I'm sure that probably some of you didn't understand what I said, but let's meet at the discussion corner. I can go through all the details of what I said. And I believe that this is the way forward. Using the language that we have is actually very powerful, can do everything that we need. And that's it. I hope I convinced you that the path to the callback heaven is narrow and few go through it. Okay? Thank you.